Hi YouTube, Tim Unkert here. In this video, we're going to look at evaluating algebraic expressions with fractions and mixed numbers. Okay, so let's look at this first one here. So if we look at the first one, we've got the expression 4/5 x plus 2/3 y. Okay, so that expression when x equals 5 and y equals 3. So I'm going to take the value 5, put it in here where x is, and I'm going to take the value 3, put it in here where y is. So our problem becomes 4/5 times 5 plus 2/3 times 3. Okay, now another way we can write this 5 here, let me just erase these out for a minute and write the 3, is I could rewrite this as times, let me just change this a little bit, times 5/1. So multiply it times 5/1 and multiply this one times 3/1. Okay, so what happens here is we get the 5's canceling out. We can just replace these with 1 and 1, and the 3's canceling out here, and we can replace that with 1 and 1 as well. So we do 4 times 1 divided by 1 is 4. So we have 4 plus 2 times 1 divided by 1, which is just 2/1 or 2. So we have 4 plus 2. And that expression evaluates to 6. So 6 is our solution to number 1. Okay, so take a snapshot. I'm going to clear the stuff up and we'll move to the next problem. Okay, so let's move on up. And this time, we've got this expression -5/6 x plus 4/3 y. And that's when x equals 12 and y equals 6. So instead of x, we're going to put in 12 here. And instead of y, we'll put in 6 here. All right, so let's go ahead and write this out. So we have -5/6. And I can do the same thing. I can write 12 as 12/1. Plus, we've got 4/3. And I'm going to write 6 as 6/1. Just remember, anything divided by 1 is itself. Okay, so we'll do -5 times 12, which is -60. And we'll divide that by 6. So -5 times 12 is 60 over 6 times 1. Or we could cancel out beforehand, but let's do it this way. And then we do 4 times 6, which is 24. And that's over or divided by 3 times 1. Remember, the fraction bar does indicate division. So if I continue to simplify this out, I get -60 divided by 6. That is -10 plus, now we have 24 divided by 3, which is 8. So this expression evaluates to -2. Now, just remember, when you add two numbers of differing signs, you're going to subtract the smaller number in magnitude, or the smaller number in terms of the distance it's away from 0 on the number line. So it's absolute value. So the small number is 8. So we're going to take 10 minus 8. And that's going to give us 2. But we always take the sign of the larger number in magnitude or in distance from 0. So we'd make this -2. So that's what this one evaluates to. Okay, take a moment, take a snapshot, or stop the video, write this stuff down, because I'm going to erase it. We'll move on to the next one. Okay. Next one. Okay, this next one we have 4/7 x minus 3 2/3 y. So we have a mixed number, and we're evaluating when x equals 4 and y equals 9. So I can write this as 4 over 1, and this is 9 over 1. We'll put the 4 here, and we'll put the 9 here. Now, what will help with the mixed number here is we want to change this to an improper fraction. So to do that, I would multiply 3 times 3. That gives me 9, plus 2 is 11. So 3 2/3 becomes 11/3. Okay, so I'm going to rewrite this as 4/7 times 4 over 1. And then we're going to subtract. Remember, 3 times 3 is 9 plus 2. So 11/3 times y, which is 9. So we're going to write it as 9 over 1. Whoa, that parentheses got a little bit out of control there, but this one's nicer. It's cleaner. So we can simplify this a little bit. So 3 goes into 9 3 times. So I'm going to cross this out and write 1. Cross this right out and write 3. It makes our problem a little bit easier. So now let's go ahead and finish this up. So we do 4 times 4 is 16. 7 times 1 is 7. We're going to subtract 11 times 3, which is 33, over 1 times 1, which is 1. Now, to subtract two fractions with different denominators, we want to get a common denominator. And we can do that by multiplying 33 and 1 by 7. So I'm going to multiply both the top and the bottom here by 7. So when I do that, our problem becomes 16 over 7 minus, let's do up here, 33 times 7. So 7 times 3 is 21. Bring up the 2. 7 times 3 is 21 plus 2 is 23. So we get 33 times 7 is 231. So we're subtracting 231 over 7. Now to figure this out, let's look at the numerators. We're essentially adding, another way we could think of this is 16/7 plus a negative 231 over 7. And if we did that, we're adding numbers of different signs. So we're going to take the 231 and subtract the 16 from it. And we're going to borrow from the 3. So make that 2, make this 11. 11 minus 6 is 5. 2 minus 1 is 1. And then 2 minus 0 is 2. So we get 215. So this is 215 over 7. And let's make this into a mixed number. So we're going to take 215 over here and divide by 7. So 7 goes into 21 3 times. 7 times 3 is 21. So we subtract that, we get 0, but we can bring down the 5. 7 goes into 5 0 times, and we have a remainder of 5. Okay, so this as an improper fraction, or as a mixed number rather, is 30 5/7. And that's all we have to do for that one. Okay, take a snapshot, pause the video, write these problems down. I'm going to erase it. We're going to move on to number 4, which will be our last one. Okay, so let's erase. Bring this down. Okay, so we have this expression 6 6/7. Get the pencil here. 6 6/7 minus 2 2/3 y. So 6 6/7 x minus 2 2/3 y. Okay, when x equals 6, we'll write that as 6 over 1. And we'll place that where x is. And when y equals negative 2, we're going to put that as negative 2 over 1. We'll put that here. We want to change these mixed numbers to improper fractions. So 7 times 6 is 42. plus 6 is 48 over 7. So I have 48 over 7 times our x value, which is 6 over 1, minus 3 times 2 is 6, plus 2 is 8, so minus 8/3, times negative 2 over 1. Okay, so let's go across. So 48 times 6, we can't simplify anything. It would be nice if we could, but we can't. So we're going to do 48 times 6. So 6 times 8 is 48. Bring up the 4. 6 times 4 is 24, plus 4 is 28. So 288. That was a fun 8. 288 over 7 minus, okay, so 8 times negative 2 is negative 16, but we're subtracting a negative. It's like adding a positive. So I'm going to change this to plus 16 over 3. Now, if we add two fractions with a different denominator, we want to get a common denominator. I can do that by multiplying this first one by 3 over 3, so the denominator of the other fraction, and then the second fraction by 7 over 7. So we'll get a common denominator of 21. Okay, so now we got to figure this out. 288 times 3. Let's just do that right here. 288 times 3. So 3 times 8 is 24. Bring up the 2. 3 times 8 is 24, plus 2 is 26. Bring up the 2. 3 times 2 is 6, plus 2 is 8. So 864 over 21 minus, okay, 16 times 7. So 6 times 7 is 42. 7 times 1 is 7, plus 4 is 11. So 112 minus 112 over 21. So we want to do 864 minus 112. So 4 minus 2 is 2. 6 minus 1 is 5. 8 minus 1 is 7. So we get 752 over 21. Let's see if we can simplify this a little bit before we figure out the mixed number. So unfortunately, so 2 plus 5 is 7, plus 7 is 14. 14 is not divisible by 3. So we can't really simplify it that much. 21 is divisible by 3. 2 plus 1 is 3. So that makes the whole thing divisible by 3. Let's just go ahead and divide it. So 752 divided by 21. How many times does 21 go into 75? Goes in 3 times. 3 times 21 is 63. 75 minus 63 is 12. Bring down the 2. 21 goes into 122 5 times, so 5 times 21 is 105. And so we have a remainder of 17. So we can write this, and let me get some of the stuff out of the way. Okay, and we can write this as 35 and 17 21sts, or 17 over 21. And boom, we are done with that one and done with our problems today. Hopefully you found this video helpful. If you did, please like and subscribe. Also, remember, I will have a worksheet with solutions on this topic available for from TeacherPay Teachers for 99 cents. Link is in the description. Also, the website, timunkert.xyz, is in the description, where we have other math content as well, if you want to support the channel. Thank you. Hope to see you in the next one.